Hello, everybody. This presentation will be about Evil Maid for modern AMD UEFI-based platform on Qubes OS. And yeah, short agenda, what I will be talking about. Firstly, I will introduce myself again for those who haven't heard me last week. I will explain what Evil Maid attacks are, how can we protect from them. So basically, what is Evil Maid? Then I will shortly describe how it was created for Qubes OS, what its status is, what have I done to enable the Evil Maid for AMD platform, what have I done to enable it for TPM2. Also, I will try to present some small demo, although incomplete, unfortunately, but still. And then we will move to questions and answers. So I'm Michał Żygowski. I'm a firmware technical leader and engineer at fwupd Embedded Systems Consulting. I'm a core developer. I maintain Braswell SoC, PC engines, Protectly, and also Liberty platforms. Recently got merged my coreboot port for their Optiplex. I'm interested in advanced hardware features and firmware features, coreboot especially, and various security solutions. You can contact me on this social media if you want. So what Evil Maid attack is? I think you don't want to meet such maid in your hotel room, and you certainly don't want to that maid to work on your hardware. Yeah? So in this presentation, you will get to know how to at least protect from certain attack surfaces from the Evil Maids. So a short recap how Evil Maid works. For example, in Qubes. So Qubes OS came with an idea to use TPM to seal various secrets, including the LUKS disk encryption key, freshness tokens, etc., etc., and to maintain those secrets on an external USB stick. This USB stick shall be used to provide the secrets to the TPM to unseal it and unlock the disk from which the Qubes OS should boot. In such case, only the owner of the platform can boot the system. So it was mainly prepared to protect to limit the impact of injecting keyloggers, password sniffers, and yeah. So Evil Maid attacks are mainly a scenario when, for example, some maid or room service came to your hotel room and you're, for example, taking a shower, and the maid sees your PC and just plugs a USB stick with some live operating system image, boots it, installs some keyloggers, password sniffers, and, for example, leaves the room. Then the machine owner launches the machine, types his passwords, for example, the operating system login, disk encryption password, etc. And it's everything. It is logged by the backdoors, the keyloggers. Then the Evil Maid comes again, for example, next day, boots from live USB image again, and just retrieves from the passwords from the keyloggers or password sniffers which were installed yesterday, for example. And such an Evil Maid can enjoy a new laptop because she can encrypt the disk and, for example, have the platform owners, PC owners' sensitive data. So, like, the first phase is quite simple, and for a modern machine, should take about, for example, 2 minutes to boot the USB and install malicious software. While the second phase also requires only 2 minutes because it's booting again and reading the data. So the reward of this operation is quite very high, because you have ownership of a new PC or very sensitive data. It depends on who the owner is, and it basically is a cost of a single USB stick and few minutes of time. Yeah, so we want to use the Evil Maid to ensure that the state of the platform is known to us and it's trusted. But if we can trust the hardware and software use, can we still feel safe? So I think in modern platforms, it is not quite true that we can feel safe. Firmware is more and more complex, and the attack surface is more wider than before. Also, in recent years, the attacks were more focused on firmware, where the persistence of an attacker is much higher. So how to determine if the state of the platform is still trusted and the hardware, firmware, or our software has not been tampered? So there is a concept of trusted execution and trusted computing. And the trusted computing group came up with an idea to have a dynamically launched trusted environment, which is called DRTM. So dynamic root of trust for measurement. As you could, for example, hear Piotr's presentation for a moment, it can dynamically establish a trusted environment when it doesn't require any static code, which is, for example, read-only, but it can dynamically, in any moment of time, since power on, establish a trusted environment. And what we need for such DRTM? First of all, a trusted platform module by Trusted Computing Group is a mandatory component. It is used to store the measurements of our firmware and our software. It also can be used as a cryptographic coprocessor. And we have to have hardware support for the DRTM feature. For example, on Intel Silicon, it is Intel Trusted Execution Technology, while on AMD, it is called Secure Launch, or also alternatively for certain people called SKINIT, as the security instruction name is. So for those who don't know, I have also presented the anti-Evil Maid last year on Qubes OS minisummit 2019. So a short comparison how the DRTM look like for Intel Silicon and AMD Silicon. Of course, for both hardware vendors, TPM is a mandatory component. And yeah, for example, Intel TXT requires certain code modules that shall be executed. First one is the BIOS authenticated code module, which is loaded by the platform firmware, and SNIT ACM, which is loaded by the operating system bootloader. The only known implementation last year was the tboot, or also called Trusted Boot. It is a project led by Intel that provides a reference implementation of DRTM for Intel TXT. Yes, and another requirement is that the BIOS needs to enable virtualization, both the virtualization extensions and the IOMMU, also called VTD. And its responsibility is also to load the ACM correctly. Intel TXT also introduces many getsec sub instructions. These are called also leaf instructions, which are used to load the ACMs and perform specific actions during the DRTM boot. So compared to Intel TXT, AMD Secure Launch doesn't require any authenticated code modules or any blobs. The only requirement is that BIOS should enable the SVM. So this is an equivalent of the virtualization technologies in Intel. Compared to Intel TXT, AMD Secure Launch also has only one secure instruction for DTRM, and it is called SKInit. 1 year ago, there was not any complete implementation that could leverage this feature, but we had started some work on TrenchBoot already, and now it has come to a state that it is already usable. So how one can install the Evil Maid? So basically, it's a matter of executing the Qubes DOM0 update Evil Maid, and it installs all the required packages. Then one have to just proceed with the instructions which are on the Evil Maid repository README, and execute the scripts which are prepared by this package. So what Evil Maid provides? It provides additional protection by incorporating multi-factor authentication at the boot time with the Untitled Maid USB stick and the TOTP codes. So one can also define an own secret besides the TOTP as a, for example, as a fallback mechanism when the TOTP secret can't be unsealed from TPM. It's a backup in this case. Or one person may, for example, provision 2 Evil Maid USB sticks in order to have, for example, a backup or better protection, or in case one stick could be stolen. And yeah, important thing is to not use the non-default SRK password. SRK means storage root key. The storage root key is a password that is used to take ownership of the TPM 1.2 and, for example, perform authorization of certain commands like sealing the data, creating NVRAM indices, etc. By default, this key is all zeros, so it is known to everybody. That is why we need to take the ownership of the TPM and change this default password. Okay. Yes, and as I have mentioned before, one may also use some additional secret key file for LUKS on the Untitled Maid USB. But still, not all attacks can be prevented. The attacker can still sniff certain passwords and keystrokes, and the attacker also can access the Untitled Maid USB stick if it is not protected well by the stick owner. I heard about some read and heard about some fake motherboard injection with some wireless modules, radio links. And of course, not always we may trust the BIOS. So a buggy BIOS may for example, allow to bypass the measurements and compromise the BIOS. Also, Intel TXT is vulnerable to system management mode attacks. But those may only be prevented or limited by the SMI transfer monitor. Okay, so let's compare the status of Evil Maid 1 year ago. So it was available only for the Intel Silicon, so Intel TXT only. The support was restricted only to legacy boot modes, so UEFI mode was not supported. And the support covered only TPM 1.2. Now, we have also the implementation for AMD, thanks to the TrenchBoot project. We are not restricted to Intel Silicons. It could be supported by UEFI. We also have some success of running AMD Secure Launch on UEFI-based installations of operating systems. However, have not managed to test it on Qubes OS yet. And it is also available for TPM 2.0. Maybe not is available, but will be available. I have almost rewritten everything from scratch using TPM 2.0 tools. So it's not quite ready, but in a few days, I think I would be able to use TPM 2.0 for Evil Maid. Yes, if anybody is interested in this development, just check our blog post. I promise I will write something when the TPM 2.0 will be ready. So how the current Evil Maid for AMD platform installation looks like. So it comes down to a few simple steps. It's not currently included in the Qubes OS repository, so one has to use the Qubes builder to build the necessary packages. The landing zone. The landing zone is a secure loader block in the AMD secure launch nomenclature, which is similar to the Intel ACM module, but it's open source. And anybody can build this secure loader. And it is loaded into this by the scanning instruction. And this is a 64 kilobytes code application, which is protected by the DMA attacks and performs the secure measurements of the software we would like to launch. We also use custom grab2 implementation with transit support. We have not yet upstreamed these changes. The upstream is in progress. First, there are patches for Intel.txt transport implementation, and on top of that, we will have the AMD Secure Launch support. And grab2 is in this whole stack is responsible for preparing the platform to invoke the scannet execution and place the landing zone in the correct location and initialize the registers as per the development guide suggests from AMD. And yes, I have also prepared a custom Qubes package for the Evil Maid, which will support the AMD and TPM 2.0. Basically, as I have mentioned earlier, I have rewritten almost everything. I have integration of the landing zone, of the grab menu already, but yet I need to finish rewriting the sealing and unsealing the secrets. So the rest of the logic is almost done, like the non-volatile RAM indexes, definitions, PCR extensions, and etc. The second step is to install the TPM2 tools and TPM2 ABRMD with the Qubes 0 update. It will download the publicly available Fedora packages for these tools and the resource manager for TPM, just to provide us with the tools which will be required by the Evil Maid package. And the first step would be to copy the build packages from point 1 to 0 and install it with DNF. And what is still work in progress is to describe this whole process in details in the Evil Maid README in the custom Qubes package repository, and of course test the installation by booting the Qubes OS with Evil Maid entry. What is also difficult in nowadays is the access to the hardware is limited because of the COVID and work from home. So yeah, using the USB stick will not be the option for now, I think. So I will have to install, for example, initially on the same disk as Qubes OS. We'll see. Of course, contributions are welcome, and TPM 2.0 may not work well yet, as I have said. And I would like to also thank you, my colleague from fwupd, Christian Habel, for helping developing the multi-boot support for secure launch in grab and landing zone. So what challenges I have to face when I have been porting the Untitled Maid for TPM2? First of all, TPM2 is not compatible with TPM 1.2. This whole software stack is different. One has to go through the specifications once again for the TPM 2.0. And these, unfortunately, are quite huge and written in very technical language. So it is quite time consuming to get familiar with. And this is mainly most of the time I have spent for the past week, and was trying to understand how the theory of operation of whole TPM 2.0. Yes, and some few information about how TPM 2.0 works. So basically, the whole concept of sealing and unsealing data is quite different. For example, first we're creating some contexts. TPM 2.0 library is all about context. Each key creation blob to sealing blob creation is based on context. And when created, they can be, for example, loaded to the TPM 2.0. So they are loaded into the internal RAM of TPM 2.0, and then they can be sealed and made persistent. There is also a utility called TPM2 eviction control, or evict control, I don't remember now, which is supposed to make these sealed data persistent. Of course, like in the TPM 1.2, we can also seal the secrets for various with various policies. These can be passwords, HMAC sessions, or PCRs itself. There are many combinations. What also TPM 2.0 allows is to have a mixed policy, like we can logically OR the policies or AND the policies. So the combinations are also almost limitless. And another thing that is quite interesting about TPM 1.2 is that it has 3 main hierarchies. Compared to TPM 1.2, there was only one hierarchy and one authentication password. So the SRK was used for almost every operation. But TPM 2.0 also introduces the platform hierarchy, owner hierarchy, which is an equivalent of the storage hierarchy, which was present on TPM 1.2. And there's also an endorsement hierarchy. So it introduces some kind of flexibility, like we can have a platform hierarchy that is used, for example, by the firmware to access the TPM and control various features. Like we cannot, for example, enable the SHA-256 banks without knowing the authorization of platform hierarchy. So we can only, for example, enable these banks via BIOS setup. And there is the owner hierarchy for the hardware user purposes, and the endorsement hierarchy, for example, for the most privacy concerned users. They all can have different authorizations like passwords, HMAC, and etc. Okay, so I would like to show you what I have been able to prepare for this presentation. So it's time for some demo. Okay, I will be right back in a few seconds. So let me switch to the demo. Okay, so here I have a KVM session with a board which is present in Frame Dev Office. This board has a BMC, so I can easily access the hardware. Okay, so this machine already has the trench boot installed, so landing zone and custom grab is already installed. And I'd like to show you that TPM 2.0 can work with Qubes OS and that DTRM PCRs are extended. So let's restart the machine. And let's wait until it brings up again.
It's waking up quite long. It's UEFI.
Yeah, proprietary firmware. Yeah, I would like to get rid of that and install coreboot or something. Yeah, we'll have to cope with that for a little longer. Okay, so yeah, basically there is a default menu entry for the Qubes OS, which is typically installed on the images, and I have added my custom entry. Then let's see how it looks like. Oh, the resolution is quite. Oh, the resolution is very bad. I'm sorry about that. I didn't know. I haven't checked that. But I will try to point you to the changes I have made to the default entry. Let me find it. Okay, so basically, besides the Zen image and the DOM0 kernel and its initial RAM disk, we also are loading the landing zone module and telling the grab that it should use the SKinit. So we have these comments like slaunch, and we point to SKinit that you would like to use the AMD secure launch feature and the SKinit instruction. And then we are using the slaunch module command to load the secure loader block, which is called LZ header. And it's present on our boot partition, like here. And the rest of the entries remains the same. So we have the Zen, the Linux, and the initial RAM disks without any changes. Okay, so let's boot it now. I will press Ctrl X. And we see that it was on the screen, the secure launch was loaded. And let's wait for the Qubes OS to finish launching. I see Piotr on the screen again. Is everything okay? Okay. It seems like it's good. Never mind. I'm just confused about my recent dropouts.
So I assume what we will show right now would be just that we have PCR 17 measurement.
Yep, exactly.
Okay.
I haven't managed to do anything more in this short time, unfortunately.
Yeah, that is like already very cool.
Yeah, I almost finished, but pity.
It's always almost finished.
Yeah, always. Okay, let's do this. And there we go. We have the PCR 17 and 18 extended. Typically, where DTRM is not enabled and the security instruction is not invoked, the TPM in range 17 to 22 is filled with FFFFF. So if it is 0, that means that the secure instruction has reset those DRTM PCRs. So basically, we will use these PCRs to seal the secrets and unseal them on the boot process of Qubes OS. Okay, I'll go back now to the presentation. Okay. So a short reference of the code and repositories I have used currently. Yeah, so we have the landing zone Qubes package I have created. The landing zone code, which was available for some time. I have also modified the original Qubes grub2 package to my needs. So basically, I have added FreeMDep employees keys to be able to verify the packages in the Qubes builder. There's also the grub2 code, which Christian helped me to develop. And yeah, almost rewritten Evil Maid Qubes package with TPM 2.0 support and AMD support. Okay, so that's all for today from my side. So now, if you have any questions, feel free to ask.
Yeah, thank you, Michał. That was very cool.
Yeah, thank
Mike?
you.
Yeah, I have some notes. Okay, few minor clarification about Evil Maid attacks. The important point is about disk encryption, because if your disk is not encrypted, then with access to the hardware you can do much more harm. But if your disk is encrypted, then Evil Maid attack is about capturing this disk encryption passwords, and this is what Evil Maid protects against. But also, not everything can be protected. If someone installs hardware man in the middle in your keyboard, then Evil Maid cannot protect against it. But also regarding multi-factor authentication, by default, Evil Maid is about authenticating the computer, the passphrase prompting thing, to the user. So you know you are entering your passphrase into a modified system. But in the default mode, it is using a static secret, something that it shows you to you each time if you boot the current system from the Evil Maid stick, which is possible also to capture and prepare a fake boot passphrase prompt with the same secret. If someone look at your screen when you enter your passphrase or install some camera or something like that. This is why TOTP is in place. So this secret is shown not directly, but used as a secret to create one-time password, which is different each time. Well, every 30 seconds, whatever. Yeah. Okay, so regarding the implementation, will it work with UEFI? Will it also involve modified group?
Yes, basically it's all about the grub here. It's like landing zone may be used the same, but the grub must be different. Like we have to install grub EFI. So we have a working grub and AMD secure launch, but on other hardware and using simply Linux loading protocol. But now for multi-boot, it would be also possible. So it's a matter of reinstalling the Qubes OS and installing the appropriate grub2 package.
Okay. So what software components are different between AMD and Intel if we are talking about TPM2 support and definitely the landing zone?
From the TPM2 tools side, from the TPM tools. Sorry.
Sorry.
Okay, just continue.
Okay, so we have grub2, we have landing zone, we have TPM2 tools, and we have what else? And the actual anti-Evil Maid scripts. So for Intel, the landing zone will be a different thing, right? But are other components the same or similar?
Okay, so I will try to describe the stack from the beginning. Basically, we have the modified grub, which is responsible for launching the for including the correct module which is used to establish the DTRM. So in Intel, it is SINIT module, and it's a similar component in AMD. On AMD side is the landing zone, aka the secure loader. And we try to unify as much as possible the behavior of or the boot path in the grub for those two silicons, and we can use the same commands for those two silicons. Like we just need to change the sk init string to the Intel equivalent. I don't remember now whether it was sinit or just txt, something like that. And basically, grub just handles everything from this point. So it loads from the disk the module, sets the correct registers, and invokes SKINIT in terms of AMD. And when it comes to Intel, just establishes the MLE, like it was similar to tboot. So when using trainer boot, we can basically omit the tboot completely and have a unified anti-Evil Maid implementation for both silicons. Just to need either include the secure loader, which is landing zone, or the SINIT module. And then when we are booting using the multi-boot 2 protocol or Linux protocol, there are hooks inside the boot protocols in grub, which call to the slaunch grub module and just replaces the intermediate steps to launch the target kernels.
Okay. What is
so Marek, yeah, so from bottom layer, like from firmware perspective, the only difference is that at this point of time, there is no way to have open source firmware for Intel platform that support dynamic root of trust. Even with Trenchboot, like Trenchboot working on open DTRM for Intel, but you cannot have open firmware. So you maybe don't care because in theory, DTRM should protect you against any problems in GAP, which is the firmware run before you invoke DTRM. But in practice, it would be great if you have control over that. For AMD, you can have like completely open implementation. So for example, all this KGPE DIC16 old AMD boards, which support SKINIT. So this kind of platform can be completely 100% open source SRTM and DRTM capable system. Yeah, it's way harder for Intel.
Yes,
So
yes,
this is
I
just
think-
firmware part. You can I think firmware part is not so very important. The most important thing is what Michał said. When the support will be merged in grep, then it would be first class citizen and of course Linux kernel. And then we plan, of course, we have on roadmap support for Zen, but it's like more October area than earlier. But yeah.
Yes. So in the current shape, what can be measured? So everything that grep loads, like Zen binary, kernel binary, InitialFS binary, and stuff like that, right?
Yes, and it can also measure, for example, the command line. We did also measure the command line for correctly for the Linux kernel.
Yes, that's a
So,
very good point also.
Yeah. So basically, what grep loads can be measured by blending some.
Okay. Yeah. Marek?
Yep.
Questions?
I have also a little question about TPM2 because I'm not very familiar with that. You said there are different key hierarchies there. Are they connected in any way? Like, can you reason that those two keys come from the same TPM? Or?
Yeah, sure. So as I mentioned, there are three hierarchies on TPM 2.0. There's platform hierarchy, owner hierarchy, and endorsement hierarchy. Each of these have a different and unique seed, which is used to generate the main hierarchy key. And from this main key, each for example, context or object created by the TPM2 library is different and can be verified by other authorization methods. So these seeds and these primary keys for given hierarchies are inside TPM and they don't leave it.
Okay, but can you say, for example, you have some quote signed with the TPM, and can you get information what keys of in different hierarchies are in the same TPM, like for example for data stealing or something?
For example, yes, you can, for example, check the attributes of given sealed data. You can check, for example, attributes of non-volatile storage, and they point to the authorization methods that are allowed for given objects and entities. These are called, I think, entities in the specifications because there is no unique word to call every, for example, object that is managed by TPM.
Okay, yeah.
It's quite complicated. I have just got familiar with it in these few past days, so I'm not an expert yet, but I learned a lot.
I've tried to get through that specification, but I gave up quite early.
Okay, so I will have some small advice from my side. How did I get those information quite smoothly? So I started with the Practical Guide to TPM 2.0 book. Just briefly, I have read maybe half of the book, just the most interesting parts to understand the TPM 2.0 in terms of Evil Maid. And then I have moved to the library TPM 2.0 library specification for the interesting comments, structures, etc. and with the help of man pages for given tools, I have rewritten almost everything in the Evil Maid package.
So I read the Practical TPM 2.0 guide. It is already available free from Appress.
Yes, it is.
It's probably because of COVID, and there are a couple other positions which are very interesting. So I really recommend that book. It's also not so easy, but definitely way easier than specification.
Okay,
a lot way easier than specification, I must say. Yeah, it's just for a typical newbie to the TPM 2.0. They even describe a few approaches that the authors took to get familiar with the TPM2 specification. So they also had these problems, and that is why this book even was created.
Okay, thanks. Okay, so related to the Evil Maid, I think I've run out of questions in my notes.
Andrew.
Okay, maybe one more sentence from my side about the hierarchies. So basically, the hierarchies allow to have, let's say, a few administrators of the TPM. For example, the firmware vendor uses the platform authentication. So he may use the TPM with the authorization values of platform hierarchy, and can only access, for example, these entities which are protected by the platform authorization values. And there is the owner hierarchy, which is an evolution of the TPM 1.2 SRK. And the owner can use, for example, any entities with its own defined owner authorization. And there is also the endorsement authorization, which can be used for by the user for the most privacy concerned use cases. Like it's a way to administer the TPM by multiple people, and they and with the possibility to not interfere with each other.
Okay. Does it also mean you can easily use TPM for different applications, like the same TPM for Evil Maid, but also for some sealing some data inside the operating system, and maybe also
exactly.
some VM? Okay.
Yes, exactly. Okay. You can have various policies for given objects. For example, you first need to, for example, to pass the owner authorization to create an object, but later, if you defined a policy that doesn't require the owner's authorization, but kind of other authorization methods, you can freely use it, even not knowing the owner's authorization value. Like, this is quite cool.
That's nice.
Yeah. If you satisfy the policy, then you can do anything. But most of the commands require the authorization at first.
Okay.
So Andrew, any thoughts about this Evil Maid stuff?
So I do have a couple of observations. One very minor one. It isn't actually required to enable SVM in systems. Specifically, the SVM is a part of how hardware deals with it, but there's also an option to be able to enable SKInit whilst prohibiting the operating system from using SVM, and that leads to a couple of complexities in nested virt. But for all intents and purposes, for what anyone cares about, we will want SKInit and virtual machines later on. So I think that's all fine. The other thing to say, based largely on working on the landing zone, is that is that various bits of it are still a work in progress, and we are making some improvements in some of the security guarantees in it. It's certainly fair to say at the moment that it functions, but we have some areas we'd like to tighten up on the security side of things.
Okay. So there was also a question on what exact model of the Supermicro board we're using. Michał, can you express that? It should be on slide, to be honest.
No, I haven't included it on the slide, but it's Supermicro Super Server M11 SDV.
Okay.
With an AMD EPIC processor, 3151.
Okay, so, and yeah, so this is also, it is important to say this is early launch use case, and next week I plan to consider during my DRTM for VMs discussion more about late launch. I believe it would be very theoretical, but maybe when we have this presentation about early launch and Evil Maid, are there any use cases that we think would make sense in case of early launch? So right now we have this anti-Evil Maid part, but do you envision, Marek, Andrew, any other use cases for early launch?
I think it nicely provides some measurement of the whole system. If we will get to a static, like read-only DOM0, then the measurements of DOM0 kernel and file system hash and stuff like that would provide you some external proof of what you are running. So I think that it is very useful.
Okay, that's
I think it's worth saying that various other bits within the TrenchBoot project are leading up a proposal that has been floated on the Zendeval mailing list about a thing called DOM-B, or the boot domain, which is something targeted for rather better, rather more fine-grained measurements of what you're starting up. So the idea is that DOM-B would eventually be a small static microkernel that can come up, check the measurements of all the other domains in memory, and set them up with appropriate permissions before letting them launch. And then DOM-B would exit and go away.
So we will call it DLME in this DRTM, yeah?
Well, not quite. I think the way you would envisage this is you go through Grub, whatever gets upstream in Grub. We do the dynamic launch. We at that point we throw away all of the UEFI firmware because UEFI is terrible. We start again from a rather better clean slate. We start up Zen as normal via as I guess technically the MLE at this point, and there'll be a number of domains in memory that we construct and get ready to run. And then the first thing that runs is DOM-B, which checks the measurements, does whatever it needs to, and unpauses the other VMs. So it's a rather, it's a better way of doing fine grain splitting up of responsibilities to avoid having a monolithic, all-powerful DOM0 as the first domain that runs.
Wouldn't it be the best to just get rid of DOM0 like in DOM0-less ARM approach?
you're assuming the rest of the system will function if you get rid of DOM0.
Yeah,
too much.
I'm just wondering if
you still rely on.
But I think you can limit DOM0 using XSM, no?
So this will also address problems like that. What currently exists isn't terribly flexible. What you end up doing is you create a monolithic DOM0, it boots up and it coordinates building a second hardware domain that has fewer restrictions and then may or may not exit itself. It's not terribly flexible, and there's work going on to improve it.
That's definitely something very interesting to have.
Like I said, there's a design doc currently out on the Zendevel mailing list. Feel free to go and read it and provide comments.
Yeah, actually,
I'm sure the Trench Boot folk would appreciate views on the matter.
Yeah, so Marek, what do you think in light of Qubes OS evolution, and like does DOM0 fit by any means? And maybe like trying to get back to Evil Maid, because I believe this DOM0, DOM-B would be more early launch usage or late launch usage?
I think it's still early launch use, because you measure all these things at the beginning when you start, whether it's monolithic DOM0 or multiple smaller domains with more fine-grained permissions. The direction we are developing right now is rather disaggregation of device handling. So DOM0 is still all powerful, but is as much isolated from the external world as possible. So we've done it long time ago for network devices and also USB devices. Now we are focusing on graphics and audio devices. So the goal is to have DOM0 that is only doing domains administrations, like starting, stopping, and stuff like that, but with it being totally isolated from external world. We also have some ideas how to do that for storage, these controllers, stuff like that. So this is the direction we are currently going. And it would be also nice to have this DOM0, which is isolated from hardware as much as possible, to also have only the powers that it really needs, like creating a domain. But after starting a domain, DOM0 in our current approach does not need, for example, inspecting VM memory. So we can also think of protecting stuff like that.
Okay, from user's perspective, what's the interest for Evil Maid, and like how does it look like in community? Do you think like improvements in that area are welcome? There would be a user base for that in Qubes community, or it's rather like very limited user base and like only for really paranoid people?
It is for really paranoid people, but our user base is about really paranoid people. So yes, there is interest for that. And also mostly because it's very attractive for laptops, which sometimes you do leave unattended in maybe not totally untrusted places, but still you sometimes need to sleep, for example. So this is very attractive thing to have. One point that is related but currently totally missing is doing the same, but not with the fresh system startup, but with system suspend. Because yeah, because currently, if you suspend the system, all the secrets you had in RAM are still available there. But also, even if you start your system with anti-Evil Maid, you do not detect any modifications possible that could happen when your system is asleep. I'm not sure if you've seen a recent variation of Thunderbolt attack, which also modifies the system while it's asleep. So things like that.
Okay, so yeah, so this is
a case for late launch, possibly.
Yes.
Okay,
so late launch specifically on the S3 resume path would allow you to reestablish the trust in whatever you want at that point.
I just wanted to mention one more thing I have forgotten to add to my presentation. When I compared the AMD and the Intel, I forgot to mention that AMD processors typically, all AMD processors have available the scaling instruction, while the Intel TXT is limited only to vPro platforms. So you have to buy a high-end machine to leverage that feature.
Yes, it's also not very easy to find one because you can find a machine that in theory works, but there is some missing BIOS support or something like that. So, for example, it is there, but you cannot enable it.
Yes, indeed.
Yeah, so I believe like maybe last point from the discussion about anti-Evil Maid, Qubes OS, and DTRM in the form that we have right now is kind of first how we would package that and deliver that to people in area of AMD, like distinguish between, okay, this is AMD platform, it has different way of enabling DTRM and trench boot, and this is Intel platform, it has different way of enabling that. That's first point. And second point, it would be great to wrap up with some thinking about how to set the project and like build a budget and propose that to the organization that can sponsor that effort if there is enough interest in such security feature.
So first, regarding the technical approach, how to package it and make available, that's why I asked about differences between Intel and AMD. Because currently we have an installation script that set up grab, copies related stuff into boot partitions, stuff like that. And this script could detect what platform we are running on and setups, right? So I think that is not very complex to careful packaging to have everything needed to set up either AMD or Intel setup. Regarding organizational, like setting up project, we can we have also some donations from the community. We can project based on that, or set up a project based on NLNet or OTF or something like that. The funding of this work.
But do you think this is like valuable enough to get this this kind of funding, or this is kind of, it would be hard?
I think yes, because that is laptops are currently main platform for Qubes, and while AMD laptops are not majority of the market, but there are definitely more and more of them, and also TPM to support available. So Evil Maid with just Intel and just TPM 1.2 is less and less useful.
Okay. I don't know, Marek, if this is just for me, but it's like I keep dropping a little bit, like it's cutting like one word in each sentence or something like that. But it's possible to understand, but I don't know something's going on with the either with bandwidth, either with the headset, either with something.
Yeah.
Okay.
Another.
Okay. Oh, that sounds like way better. Okay, so I believe we have like last 17 minutes, and we can take any discussion related to RTM in Qubes OS. There are not much questions, like there are no questions, to be honest. Yeah. So any thoughts, any like consideration about RTMs in Qubes OS and its usefulness, and if that make even sense and so on.
So I guess one observation it might be useful to say is that one of the long-term goals of the Trenchboot project is to be able to relaunch during runtime to reestablish trust in the system. Obviously, there are a lot of challenges before that is a viable option to do. It's probably going to require driving hardware changes through the main CPU vendors to make it feasible. But it is the long-term goal is to be able to take the technology that is here and be able to, at an arbitrary point in time, re-establish trust in the system. So immediately after S3 resume, but maybe periodically every 6 hours or something like that, because there are use cases for which that is important. And it would be nice to be able to do, rather than only gaining trust the next time you reboot the system. So I suspect that long-term goal might be interesting to some of the people who might use Evil Maid already in Qubes. So I just thought I'd put that out there.
Yeah, so I believe like it is very important to build community and user base, and like to harden whatever we have right now. This, of course, like hardware change means like long time, and
right.
Like
the point is, no one uses technology until it's easy to use. You've got to get it easy to use, and then people will start using it. And there are certainly a number of things in this area that are helping with the ease of use.
Yeah, and I believe in area when we will hit the problems with hardware, and we will know the limitation of hardware in case of having Trenchboot in Qubes and in other environments. And when users start to use that, complain and see some problems, and maybe someone will, from security community will try to attack that, will present something that there are not everything is as good as it should be. Then maybe we will have more power with the community to say, okay, there are like huge user base that using that. There are products that building on top of that. There are companies that using that for protecting the integrity of the platform, and maybe that can even help pushing silicon vendors, hardware vendors to improve the situation.
Yep.
And I believe like what's important is like to explain, to educate people, and of course that's where this kind of conferences like this minisummit, where people from hypervisor world, from operating system world, from firmware world may sit together and discuss. Okay, these are the problems on these interfaces. These are the problems with the design, which is like maybe not yet fully set. But if we will express that, I will push the message out there. I hope, like I'm pretty sure there will be, it would be easier to have some proofs that okay, we discussed that there are many people that claim this is a real problem, and thanks to that we may convince some players to fix the things. Okay, any other thoughts, Michał?
I would just wanted to agree with Andrew, as if you make the technology way easier to use, there will be a user base. Yeah, so I think the packages are a step into this direction, the Evil Maid packages for TPM 2.0.
So we just do apt install, I don't know, Evil Maid, and for our platform everything is set. Yeah.
Yeah, ideally the Qubes .0 update and Evil Maid and everything is okay. Like we can set up our own, for example, package repository for Qubes and have the deployment of our packages for AMD even, or whatever we would like.
Yeah. Ideally, I think if Evil Maid would be convenient enough to set up, we would like to give add an option during the installation to have Evil Maid simple install with the whole system. So there is no separate step. You just tick a checkbox and it's done. So that's some goal for the future.
Particularly when some of the trench boot functionality gets upstream into the relevant projects, this should become a whole lot easier to do.
Indeed.
I think,
but there's a problem of detection of these features, like for Intel Silicon, it is not always available, etc.
At which point you make it easy on the ones that we can make it easy on. But that's still making it easy in more cases than previously.
Yes. Okay.
There is also a question about how to validate that before this, like we can introduce that in more production workloads. So for example, how to validate Evil Maid. So definitely I did some research and get some proofs that various researchers were able to emulate Intel DRTM, Intel DXT, and get sec instructions. And as you, Andrew, probably you pointed out, and Daniel, that emulating SKInit is trivial, and there are even some maybe snippets that can do that. So maybe this is also something that should be on our development path to use that emulation to exercise some models and to exercise higher layer of our stack.
So fundamentally, if your emulation is good enough, what is the difference between a virtual machine and real hardware? All of this comes down to where safely stashing the secret to begin with, and there's no way around that. The initial provisioning of the platform is something you have to account for in your eventual security model. But certainly from a testing point of view, we can do whatever we want to make this easier to test in scenarios. Again, testing the mechanism, not necessarily the fully rooted security.
Yeah, so I assume definitely we should also consider that as a component of during our development. So from perspective 3M Dev, we definitely need some setups. Like when I work with this SRTM, part, it was kind of hard to me to have correct setup in Qubes OS development environment, and like to, you know, if I will mess up something, to quickly recover and so on and so on. Because definitely when you're developing Trench Boot, you have the same situation. You can easily mess up something, and then you should be able to quickly revert and start from the beginning, like you know, code test, and you know, and get back with the result, and code test, and so on and so on until you get correct implementation. So, but I believe this is part of the not next week but the week after, and I believe like Marek and Frederick will tell us more how to set up, or what are the tools to set up development environment for Qubes. And maybe Marek, you could kind of also say, like, in light of these features that we're presenting, like this SRTM part. So you already helped me with setting up a SRTM development environment, but it's still, you know, like not there. So what if I will try to do, for example, VTPM design? This could be even like more night sessions trying to, you know, lay out everything. So I will have, or developers of 3MDEP or any developers will have reproducible development environment. And same thing for DRTM. Maybe you have some ideas right now that can be used.
Yeah, I will in my presentation, I will also say various testing methods we use. This includes some Unix testing, integration testing using virtual machines. So is Qubes running nested in another virtual machine, but also testing on real hardware and how and what is our current approach and what are ideas for the future. But testing features that rely on very specific hardware, like TPM, like specific DRTM, will probably require running on real hardware, because I have quite bad experience with testing hardware support using virtualized environment. I know QEMU emulate a lot of stuff, but it's quite different from the real thing.
Yeah, I also concur with that. Attempting to develop a hypervisor whilst nested, it's fine for the regular bits of C code. It is not fine for anything that is actually touching hardware. Mainly because the bugs are in with interactions with the hardware itself.
So you probably know that 3MDEP got this lab with remote test environment, our open hardware platform, which just hooks into those right now AMD Ryzen to KGP D16 to this embedded EPIC platform. I believe sooner or later we will hook that also into Intel. Of course, when we will quite mature and we will be blocked by other entities in the Trench Boot ecosystem to move on with AMD, we will just switch to Intel and we will exercise Intel version of Trench Boot. And maybe we'll provide some public knowledge about that, how to set up that part. Okay, so I believe like we going to an end. I'm just wondering, Michał, is that like every AMD platform got SK init? Is like all of them got SK init, or is just something you need something special?
Of course, there is a barrier of older platforms that may not have this SK init, but as far as I know, all boards have the SK init right now.
Everything.
So that's the difference with the Intel.
Has SK in it, I believe.
Please repeat, okay. Andrew. I have not heard.
I think everything from the K8 onwards has SK in it. So yeah, don't worry.
Something like that.
Literally everywhere.
Yep.
Okay, that's very good. So I'm also wondering like what's
what's
yep.
more of a problem is whether you have a TPM in the system. So yes, basically any AMD hardware anyone would be using today has the SK in it instruction, but they need a TPM in a compatible TPM, and that will be the harder thing to find.
Yep.
Yeah,
you have
that's
to know
kind of
whether to use 1.2 or 2.0. Like yeah, probably the newer can use both, but some older ones may only utilize 1.2.
Yeah, I believe like this is huge problem with TPMs. Like I'm starting to hate this environment more and more. Hooking that, like correct headers, correct pinout, pinout compatibility, and then we just today faced like very stupid situation with firmware update of TPM. So I want to downgrade the TPM 2.0 to 1.2 because I wanted to exercise a Zenv TPM, and of course the set of so you can only have firmware which do the migration between one version of the firmware to other version of the firmware from one specific version to other specific version. And if you don't have binary with correct combination of the versions, you just cannot migrate cannot do the update of the firmware on TPM. At least on our Infineon 9556, I believe this is the number.
So 9665.
9665. I'm sorry. Okay. So yeah. So that's kind of very problematic. And last thing. I wonder, Marek, like if you have any information about percentage of the user base in Qubes OS community using AMD and maybe even modern AMD platform. Can you tell anything about that, or this is a considered secret or whatever?
Generally, we do not collect such information at all, but we have a tool to upload your system configuration with some support statement like if that works or not, and it's on our website hardware compatibility list. And let me look. Where is there are definitely quite a few AMD machines, but most of them, most of the systems here are Intel machines.
Okay, those are like new AMD or old AMD stuff, because I wonder about really availability and interest in modern AMD laptops, or like I assume like laptops are main target of Qubes OS. So I'm just wondering like if because what would be the user base of AMD based Evil Maid, because like it's very kind of neat specific. And by the way, we should probably go to AMD and say to them like we can drive some sales for you because this is like very specific case. Maybe this would be not big number. Maybe we cannot convince them with those numbers. But at least like we're doing something for, I would say, free.
Yeah, looking at the mailing list threads and something like that, there are quite a few users with AMD Ryzen processors.
Okay, and with that question, I would like to close. I really appreciate that, Marek, you joined, and Andrew, you too. Like your comments were very valuable. Let's prepare next week session. I'm not sure if you both will be available next week. We will see. Definitely, we will like to talk more about different RTMs. I believe, like Michał, there will be coreboot.
I think there will be two DRTMs. Yours will be about DRTM in virtual machines, and I will talk about Intel TXT in coreboot, so DTRM with open source firmware on Intel architecture.
Okay, so thank you very
Also,
much.
In the meantime, also Frederick said that regarding AMD hardware, laptops is one thing, but also for servers, AMD have very good options like performance to price ratio. So that's
yes,
also.
suffice it to say that AMD Family 17 CPUs are currently doing fairly well overall.
Okay, so hopefully they will gain more and more attention, and we can get the very open platforms. I believe in light of modern PSP, it's not it's not so cool, but anyway, we going in the direction of opening the ecosystem and getting more support for advanced hardware features.
Yeah.
So thank you very much.
Open source PSP operating system is in development. For those that don't know, some students are working on that using vulnerabilities and code execution on PSP. So I have talked with a mentor of these students, and yeah, he was trying to consult to get some consulting on coreboot community.
Okay.
It was quite fun to talk about.
Yeah, so we're a little bit out of time. So thank you very much. Thank you for watching, and stay tuned. Next we will have another live session. Bye bye.